Okay, kids, we're back for the rock concert experience. You want that rock concert experience, and you got your 500-watt stereo, you paid for it. You might as well use it for something, right? So let's go. Let's figure out, you're 1 meter away from your speakers, and maybe you're in your car, your speaker's a meter away, and you're cranking down the road. You want to be in a rock concert while you're driving, okay? Nothing distracting about that, right? Perfectly safe. So now, how many watts would you need to use? Okay, so let's go back to our equation. You want the rock concert 120 decibels. All right, so 10 times the log. Now what we're going to calculate this time, this is watts over area, but this is also power over area too. Power over area. So I was using the units before to show you this. I said watts over square meters. Those are the units. The symbols, either way, it doesn't matter, but I'll just put this in here, power over area. That's what we got on top here, power over area. Okay, so this time, we want to know how much power, how many watts that we're going to need to get that rock concert experience. So P on top. Sound, remember, always 4 pi r squared. Okay, sphere from the sound source. And we're 1 meter away from that sound source, so that's 4 pi 1 squared. Okay. Divided by 1 times 10 to the negative 12. All right, so solve for power. How many watts do we need out of our 500 watts? So what you're going to have to do, remember last time the calculations I said work from the right to the left. Do this first, then logify, multiply by 10, got your answer. We're going to do the opposite. This time we're going to work from left to right. We're going to solve for this, isolate this. We have to go through, we have to get this out of the way first. So first thing I do, 120 divided by 10. Anybody got a calculator? Okay, gotta make sure we get it right. Calculators know, by 10, 12. Okay, so 12 equals the log of this stuff. Now I gotta deal with the log. Before it was right, left, now it's left to the right. So I got 10 divided, got my answer. Okay, log, I gotta get rid of that log. Anti-log. Well, actually back in my day, we used to call it the anti-log. Sounds antiquated. Inverse log. Okay, that's what you're doing. So when you've got your calculator and you've got a log button, you're going to have a 10 to the x. Remember we said exponents, that's what logs are, they're exponents. So actually, I already know the answer to this because I'm all smart and stuff. So I know that the inverse log of 12 is 1 times 10 to the 12th. That's what that is. It's log, it's an exponent. This is going to be 1 times 10 to the 12th. But let's show you, because it might not be so easy. You might get something like 128.2 over here, and it's not going to be so obvious, so we have to know how to use our calculator to get rid of the log and get rid of the log on this number to the left. Okay, so what I'm going to do, okay, here we go. So I'm going to hit second function log, and it's asking me, what do you want to put in there? What do you want to put in there? Well, I want to do second function log, because I don't want log, I want second function log. I want 10 to the x, 12. So I put the 12 in there. Okay, I'll close bracket that, boom, we get it. And like I said earlier, 1 times 10 to the 12th is the answer to the inverse log of 12. So this comes out to be 1 times 10 to the 12th. Okay, now I've got this stuff over here to deal with. I've gotten rid of this. Actually, let me just kind of put this all right up in here. So 1 times 10 to the 12th. Let me do that. No, I won't let you. Oh, geez, Billy, relax. So angsty, Billy. He's always so angsty. All right, so now I'm going to multiply by this, and I've got my answer. So let's go ahead and do that. So 1 times 10 to the 12th multiplied by, let's see, multiply answer by 1, second function exponent, there we go, negative 12 equals 1, right? It makes sense, right? 1 times 10 to the 12th multiplied by 1 times 10 to the negative 12. It's got to be 1. Woo, saw that. So 1, and then 1, this is now equal to 1. So now we got this gone. Okay, and now multiply that by this. And what do we get? Well, that's 1 times 1 is 1, 4 pi. So 4 pi is equal to the power. Now 4 pi, let's do that out, because you don't leave things in terms of pi in physics. People laugh at you. They'll laugh at you when you walk away from the water cooler. Okay, you don't want that happening, okay? So do that out. 4 times 3.14 equals 12.56. are around 12.6 watts. 12.6 watts is how much to get the rock concert experience. That's how much of your 500 watts you need. And you see, now, so, I mean, remember, we used 2 watts to get 112. And so we're going to need about, well, say 13 watts to get up to 120. But once you start cranking it up here, okay, like I said earlier, diminishing returns. So you still only need 13 watts out of your 500 watts to get your rock concert experience, okay? You don't need it to be this loud. You don't need to pay for that other 480 watts to go from the threshold of pain, because that's where you're at, threshold of pain, 120 watts up here, okay? Okay, I'm just trying to talk you out of it, okay? If you're thinking about that 500 watt stereo, I hope that I've talked you out of it, okay? But we've done some sweet problems along the way here. And so if you are working to solve a variable on the left, and, oh, let's do one more. Let's do one more. Let's say that you are listening to a rock concert at 120 decibels, and there are 60 watts being used. So you're using 60 watts of power, because remember I is power over area. How far away are you from the sound source? If you're hearing 120 decibels on the decibel scale, and you're 60 meters, or 60 watts is what you're using, how many meters away are you from that sound source? 1 times 10 to the negative 12. All right, and there you go. There you go. All right, okay, so you're going to solve for that. So you're going to, remember, you're solving something over here. So take 120 divided by 10, get 12. Earlier we went through this. We hit the second function log button of 12. We go 1 times 10 to the 12th. So 1 times 10 to the 12th. I'm doing this so I'm using easier numbers so I can do the math quicker. Of course, all numbers aren't going to be this easy, so just make sure you understand the process. So this is now gone, equal to that. We multiplied this, we got 1. So that's equal to 1. This is just like before. And now I'm going to solve for x. So I'm going to cross multiply, bring this up here, bring this down here. So we get 4 pi x equals 60. And then 60 divided by 4 pi, square root gives you x. So 60 divided by 4 pi. I'm going kind of quick here. I'll rewind it if you have to. Remember, I'm going to run out of time here. My video's going to stop. So I get this done. So 60 divided by 4, enter, divided by 3.14. It's my pi, enter. I need the square root of that. So second function around here, I go second function, square root, second function, answer, 2.19. I'm 2.19 meters away. So x equals 2.19 meters away. Okay, from the sound source. I'm going to tune something. So I got farther away, 2 more meters away. So I use 60 watts this time. So as you start getting farther away, here's another point I do want to make. Once you start getting farther away, of course, in 3-dimensional space, it doesn't work like, well, you're twice as far away, so you have to use twice as many watts. No, it doesn't work that way. It's 3-dimensional space you're cranking out here, so as you move farther away, there's an inverse square relationship, and it gets complicated. Anyways, so that would be the distance that we are away from our rock concert using 60 watts. And now, of course, with a real rock concert, people are a long way away. Right? And you can be far out there, man, like you're in a stadium or something like that. And so that's where your 500 watts. See, I told you 500 watts would come in handy. Well, yeah, it does. If you're actually at a rock concert, you're going to need a lot of watts to produce that sound and project that sound out to the audience and make that loud. All right, so we'll let that be a lesson to you. Okay, this video is getting long here. We've done more problems here. I hope you now have some understanding of how to work the problems, and I hope everything is going sweet for you kids. Okay, I need a water break.